Today on Clockspring 3D, we take this floor lamp and use it to create continuous lighting for video using the magic of 3D printing. But before we get into anything else, what have I been doing in the last week creatively? Well, first thing, I did what everyone else has been doing for a long time and printed on fabric. And it's really cool. I got myself some tulle, ballerina dress fabric. It's kind of a stiff mesh, and this is my first attempt, and I didn't even change the first layer height or the offset, and it just worked. So I did have to make sure it was held flat with my fingers to make sure I didn't bunch up under the nozzle despite having clamped it down. But it bonded well. I mean, you can pull it off if you really try, but it's really impressive. So these individual elements are quite rigid, but the whole thing flexes very easily, and it still seems pretty tough. So I'm really impressed with that. I can see why everyone's so taken with this as an approach, especially for costume-based stuff. I don't have a particular thought in mind right now where I might use that, but it's absolutely something that I'm glad I tried and have some sense of, the nature of and the difficulty of, which is low difficulty. Now, the other thing that I've been doing in the last week is twist boxes, and not for the first time, certainly. This one is something I'd had in mind for a while. It's a 4-layer twist box. Excuse this noise. Horrible. Well, especially on camera. But so the distinction with this one is that each of the parts has 2 layers, and they're geared so that when we put them together, the layers show through. So this one I put on My Mini Factory, who have promoted it quite nicely. Thank you, My Mini Factory. It was fun, but it actually came from this, which was a prototype I did a little while ago, it's the same overall structure, and it's the same concept in that the lid and the inner both have double layers. But in this case, it was a gothic kind of design, which I still really like, and I still intend to use in a different way that I'll get to in a second. But this one just didn't work as a neat print. This really needs support, which I don't. I try to avoid prints that need support where possible. So it never really worked out the way I wanted it to. So the idea just stuck in my mind though, and in fact, doing this rainbow twist box was really just an effort to get that back out of my mind and feel like I'd at least done some service to the concept. Now, someone pointed out I hadn't printed just a basic version of one of these twist boxes, so I did that. This is just a basic kind of curved hexagonal one. I like it. I mean, twist boxes are fantastic. They've been around forever, and I've certainly printed my fair share of them. But I also printed this, which is a tiny little one. I was testing some new filament and just testing a printer fix, and so I made this little thing. It's completely impractical. I'm not sure what this is actually useful for, but it's so cute, and it's very solid because the walls are still quite thick. I can't help though to think that this is something that could form the basis of a more intriguing concept. I don't know exactly what, but it's really tactile, and I keep touching it, and I'd love to make more of it, but I'll just wait and see if it speaks to me in some way. But cool, still not sure where that's going though. Now, this is something else that I have an upcoming video on, although not this specifically, but something inspired by it, an extension of it. So this was a pencil box with a kind of a gothic feel. Again, that magenta and black color scheme, which I love. It's so nice. But the box itself, the dimensions are not great, and it also suffers from the same printing limitations with the decorations on the side there. So the newer version that I'm doing the tutorial about it's bigger, the decorations are a bit more appropriate, and so on. But anyway, upcoming video, so we'll leave it for that. So I would like to lay a challenge for you. in the same way that I found something that I'd seen that people were doing and thought, I'll try that. You find something that you think is really cool and try it. Whether it's something that's technically difficult or whether it's something trivial that you just haven't done. But it's always great to just expand capabilities and expand experiences in that way, even just to trigger those ideas. And of course, when we're doing these things, mistakes happen along the way that also lead to inspiration and insight and all those things. So yes, do that. Do something that you haven't done before. When I started shooting video, I realized that I had one particular problem, and that was lighting. See, I already had plenty of camera gear and lighting gear for still photography, but for video you need continuous lighting, and that I didn't have. So I had soft boxes and diffusers and so on, but I had no way of just lighting a scene for video. What I did have though were these. This is a really cheap Ikea lamp. They're about £5 in the UK, a bit over $10 in Australia, and similarly priced in the US. And these have a couple of particularly useful characteristics. Now, first thing, heavy base, very useful for keeping things stable. So, because I should point out that light stands are obviously the alternative, and I've got those, but they're big. They take up a lot of footprint on the floor, and we're not in a huge space here, so that just wasn't practical. But these things, the base on these things, I'm not going to lift this up, is about that wide, and it's nice and stable. So yeah, so the fact that these are nice and compact is a real advantage. Now, second advantage is this pole is actually made up of segments. So these things screw apart, and also really useful, the power just goes into the top segment. So let's take this apart. And we unwind some of this winding we just incurred. So now we have this part, the socket part, separate to the rest. And what we want to do is mount it like that, because light vertically isn't really going to work for us, but horizontally is. Now, we can get rid of this thing, because that's not going to be of any use to us. And I presume I would have had to have put this on when I bought the thing anyway, IKEA stuff being packaged as it is. Let's just put this on here so I don't lose it. By the way, it's really dark over this side of the frame because this is my side lighting. Okay, so we want that to be like that. But there's one more thing that we need as well, and that is a light modifier. In this case, an umbrella. Now these things can be had very nice and cheap these days, and the idea of this is that the light is shone into it and it comes out nice and big and diffused and so on. And in fact, that's what we have up here as well. So that needs to be mounted so that the light is shining into it. So both of these things need to be kind of mounted like that. So we need some sort of clamp. Now let me put this down without damaging anything. And look at this, what I prepared earlier. It's in a state of disassembly at the moment, but simple concept. And this is something that I whipped up quickly in Tinkercad, and we're about to go through how that's constructed. But let's put this in place. So, simple concept. It's just two plates that clamp both the umbrella and the light shaft together. They're separated just enough to allow the light bulb that I'll get out in a second to fit in there. And a screw just holds the two plates together so they don't move. Then there's another screw here that just stops the thing from sliding up and down. So let's pop this on first. Unscrew that enough. And this needs to be unscrewed as well. Okay, so that, now, not all of the weight is being taken by this. So the weight, the friction of all of these pieces is stopping it sliding down, but this changes the angle enough so that that friction can do something useful. So we have that there. Let's loosen this plate. We'll just move it right up. We pop that in there. I'm just being conscious of which way I have to put this umbrella in. Maybe we'll turn around this way. And now we'll mount the umbrella in front. So just unscrew that again. And there we go. We have the umbrella and we have the light itself. Now, here's the bulb I mentioned earlier. I mean, this is a hugely bright, I mean, you can see it's physically large, but not expensive, but really nice and bright. And again, this is something like 30 watts, but very bright. I'm not going to turn this on because it's just going to blow out the entire scene. But if I lean this forwards, you can see what I mean about having to consider this gap in here. So the crucial measurements here really, and we'll sketch this stuff up in a second, are the diameters of these poles, and this one here, which is the same obviously, what sort of gap we need here, and that's kind of it. The rest is pretty arbitrary. But simple thing, and it works brilliantly. So let's get into how this is actually designed and built. Okay, so let's sketch this thing out. We'll start with a block. Divide that into 2 plates and we'll need some holes through the thing. We'll need another hole perpendicular to those to take the main support. And we're going to need a clamping mechanism to hold these things in place. Now at the moment we're only talking about clamping the 2 plates together and not stopping the whole lot sliding up and down. Okay, just making things a bit clearer there as thoughts become clearer. Now, if I'm sketching things, it tends to be, I think about these things as I go. So the sketch may well change dramatically as I'm doing things, but it saves making those changes while actually implementing the thing. So it definitely saves time. I mean, planning is always going to be a good thing, but that said, do I sketch out everything that I'm making? No, absolutely not. Sometimes working in the tool and making changes in the design tools is part of that explorative process, and I really enjoy that. But for something like this where I already know kind of what I want and I'm just trying to do the specifics beforehand to make life easier, then absolutely I'll sketch it out. So as you can see here, we've got a bunch of arrows. We need some measurements. Now, a lot of these are arbitrary, but we do need figures. I mean, obviously we have to give dimensions to things in order to make them. So let's come up with some figures for that. Okay, and again, the attachment mechanism at the bottom is kind of not an afterthought, but it's something that's not really that critical. There are any number of solutions that we could add that won't affect anything else that we're working on. So let's do that part in Tinkercad, largely because I want the 2 screw mechanisms to be the same anyway. So we'll design the screw part for the top and then we'll just see how that applies to the support as well. So here we are in Tinkercad. Now let's start off by creating one of the plates. We'll use the regular cube option. Let's give it a bit of a radius just to smooth things out. Now, one thing that's good to know is if you just use the handles to drag this thing to rescale it with a radius, that whole radius will also be scaled. So if we want the radii to remain even and each of those edges to have the same curve, we need to change the dimensions using the actual fields against the object. So we can see there that everything still has the same curve to it. Okay, so we'll make that the right height, and there we go. Okay, we have the first slab, the first plate. Okay, let's create another one, move it into place. Okay, so that's our start. So, what next? Let's have a look. We are going to need the holes through which these things are going to be clamped. Now, I always set my sides up to the maximum, but that's just me. I mean, it rarely makes that much of a difference. It's really only on larger objects that you're going to notice that much difference anyway. But I do it. I don't know why it defaults to a fairly conservative value, but yeah, it'd be nice if I could make it default to a high value. Okay, so we'll make one of them 16, then just scale that one. I'm using Shift and dragging a corner to get uniform scaling across everything. Oops, that's a rotation. Okay. And so they just need to be long enough so that they extend through the entire object. Oh, almost forgot. I need to group these two plates so that I can align the other things in the middle of them. Okay, so let's try that. And align. Oh, and I selected it before the group operation had actually finished, so that didn't work. Let's just do that again, and I'll use the relative handles anyway, in theory. Okay, that's much better. Now, these elements need to be, what is it, about 80 apart from each other? So let's just measure and see, well, let's move these things out and then see how much space we've got. Shuffle, shuffle. Okay, and 76, 75, 76, what's that, 75. Okay, let's move that across. We might actually just move them all to the middle again. Okay, so that's that part done. Now, we need to subtract those elements from, oh, actually, first let's just create, while we have a convenient subtractive element there, let's just create the hole through to support the main pole. Okay, and we are done. Now, we're going to need to duplicate these because we need one set to subtract from the top. We'll do that. And then we're going to need the other set, which should still be there, there we go, to subtract from the base. And just group that as well. Control G, of course, does a grouping rather than using the toolbar there. And look at that, that's exactly what we need. And likewise, we'll do the same thing for this vertical one as well. We'll duplicate that. And we will group it with each of those elements. Okay, looking good. Okay, so next thought is, how do we clamp these things together? Well, one of my favorite shape generators in Tinkercad is the isometric thread. It's just a screw thread with all the parameters that you need to manage it. So let's just grab one of those and let's just check the sketch. What was the diameter on that sketch? It was 16 mil. So let's just change that. 16. And let's change the segments as always, just to keep things as smooth as they possibly can be. Okay, now by changing the scale vertically there, I'm obviously changing the thread pitch as well. And I've just made that kind of just the way that I like these threads to be. It's a good compromise between strength of the actual threads and the smoothness or something. I'm probably justifying this without any actual basis. But the thing is that it's arbitrary. As long as the bolt matches the thread that it's going into, then that's all that matters. So as long as we're consistent, then that's the important thing. Now I've just hit T to make those elements transparent, just so we can see what's going on. Because the thread only needs to be in the bottom section. Now I'll just align this with the bottom. And we'll use the relative alignment tools. Okay, and now I'm just going to shuffle that up slightly. That should be good. Now, I'm just going to make a copy of this because we're going to need to use one of these to make the bolt itself. Now there are now two sitting there. Now one of them has just been made into a hole, and then we've increased the diameter by 1 millimeter. And we'll just group that. And this is where I realized that I made a horrible mistake. Well, not an irretrievable mistake, but I forgot to ungroup those two initial plates. So that means that all of this grouping that I've done has actually been grouping the subtractive elements with the unified plates. So we're going to have to go through and undo all of this. Are we there yet? Are we there yet? So we'll continue to just undo these things. Okay, there we go. So we should be able to group those. And then that should leave another set that we can group with the bottom one this time. Much better. Likewise, we've got the vertical supports we need to group in as well. So we'll do that. We should have two of those. So one for the top, one for the bottom. And now, when we group in that subtractive thread, we should see that it only extends up as far as the end of that plate because it has no impact on the plate above. That's what we should have seen. Okay, so we're back on track now. That's good. Now, what we'll also need is a hole in the upper plate to allow the bolt to extend through into the lower plate's thread. Now, that hole obviously needs to be larger than the thread. So let's go with, actually, we could just leave it at 20. Our thread was 16, so that would be plenty. So let's do that. Let's just undo. Okay. All right. Move up the sides as always, even though it's really going to make no difference. Okay, let's just ungroup so we need to align it with that thread. We might just hide a few things here just to make things clearer. But because I can't click on that, yeah, let's hide some things. Hide tool, very handy. I do like the balance in Tinkercad between the simplicity of the hide tool being hide individually and show globally, and still, I mean, there's a good compromise there between the simplicity of operation and the power it gives. It's kind of good enough, if you like, without adding complexity to the tool. Okay, so now we have that piece. We'll just shuffle it down so it's definitely going through the entire top plate, and then we'll group that. And now, well, we need to regroup that as well, of course. And now look at that. So we have room to put a bolt through. Okay, great. So let's make the bolt. So the big question there is, how long does it need to be? So we change the number of rotations to change the height because, of course, we can't just stretch that thing up because we'll change the thread pitch and then the bolt won't fit the thread. So, okay, look at that. Now, we don't want it to be quite as long as the hole that it's sitting in because we don't want this thing to end up forcing against the base of that hole. So, yeah, that looks pretty good. Because, of course, the orientation will change based on the rotation of the bolt anyway. Okay, so let's flip that over. Now, that's really important because we're putting the head of the bolt at the bottom here. So we need to make sure we flip that thread over, otherwise it's going to be backwards. Okay, let's make that 10 high. Now we sketched out the bolt's head as 30 diameter and 10 high, so let's do that. Okay, and increase the sides as always. Let's put a bit of a bevel on it just to make it slightly nicer. And center it underneath the bolt. Now I have a tendency to just throw a subtractive cylinder in there and space it around the outside just to give the thing a bit of texture. We could do some knurling or something instead, but this is really easy. It's very quick and simple. So I'll create one on one side, and then we might just shuffle it up so we can see it in place there. And then I'll duplicate that with Control D, move it to the other side. Then I'll group the two so that we can center them. So we just so that we can make sure there is even spacing there. So we'll group those. Oh, the grouping wasn't finished. Oh, look at that, it's already centered anyway, at least on that other. Yeah. Okay, so now we can Control D and change the angle of rotation. And now Control D, and we have everything we need. So group the whole lot, and our bolts should be complete. Fantastic. All right, now just as a sanity check, let's make a copy of that, and I'm doing that via an Alt-click drag. And just shuffle it roughly in place. It doesn't need to be precise. So there we go, edge it in, move it up a bit. So let's move it up so that the head of the bolt is sitting flush with the plate. And we can see we've still got clearance at the bottom there, so that should do what we need. Okay, so that part's done. So now we have the basis of the plate. So all that we're missing is, how do we stop this thing sliding down the pole? Okay, so I'm just going to take this bolt, duplicate it, and then move it down underneath so that this is really just so that we can position this thing so that the bolt will have room to be put into place. Okay, so maybe a bit more. Okay, now the end of the bolt is roughly in line with where the pole is going to be, that it's going to press against. So with that done, let's make something that this thing can actually stick into. Now, this could potentially take a bit of force, so we want to make sure that it has a bit of substance to it. So not just a cube sticking down. Let's give it a bit of an angle as well. Now, let's just set some sizing here. And I'm thinking that next we'll probably grab that roof object and rotate it into place. And that will let us just increase the contact area with the plate above it. So let's just get those into the right place. Okay. Oh, my eyes are playing tricks on me there. Let's just do this. Okay, much better. So there are any number of ways we could build this kind of structure. Now, I think in the version I'd already printed, I may have rounded some corners and things on this, but let's not worry about that right now. It certainly doesn't make any functional difference. Okay, so that's roughly the shape we want. So let's move that into place. Okay, so clearly it's not quite long enough. And it's also not centered. So let's just use the relative centering tools and center it with respect to that bolt if we can find the handles. And there we go. Okay, so let's make these things extend down well past the bolt. There we go. That's probably fairly reasonable. And extend it out a bit. Looking good. Except, of course, that these things are now in the wrong spot because the bolt needs to be protruding from the back of it. So let's just move that into place. And now we can see that the piece that we've added actually interferes with the bolt itself. So let's just bring back that triangular prism a bit. There we go. And that's as far as that bolt's going to screw in anyway. We know this because at that point it's going to be in contact with the pole itself. Okay, so it looks good. Let's just group all these things. Okay. Although, there's something we've forgotten here. That width is just not enough. There's not enough there. Okay, let's just double click to drill down into the group and let's just arbitrarily widen it. Yep, that should do. Okay. And that looks much better. Now, this thing is going to I haven't really mentioned in any of this how this is actually going to print, but as should be fairly obvious, this thing is going to print upside down. And, but first we're going to just create the actual thread hole. But yeah, so both of these plates will print so that the actual clamping surface is going to be facing down on the bed because they're fairly gentle circular curves. So there'll be no issue printing those. That's very easy by bridging standards. Okay. Now I've just created that thread hole there as well, and again I've just used a millimeter wider thread than the actual bolt itself. So that is pretty much that. Now I'm just going to delete that because that's not relevant anymore, and I'm going to place the two plates on the bed so that they're in the correct orientation for printing, because that'll just save you having to do that in the slicer. Okay, and there we are, and just shuffle them around a bit. We are done. Look at that. So simple. I mean, obviously it takes longer going through these things when you're talking about it at the same time, but easy stuff, and it's just so simple and powerful. Look at that. Look how printable that looks. And there we have it. Now I have my side lighting back in again, so that's great. But the reason that I decided to talk about this today wasn't because I thought this was something that was relevant to everyone who might be watching the video, but just because it was a really interesting and satisfying problem to solve. Now, again, I really maintain that 3D printing doesn't need to always be in aid of solving a problem or have justification, but I can't deny that when it actually does do that, it's so satisfying. It's such a good feeling to go, wow, I actually did something that was useful. But anyway, don't forget, do something different and exciting that you haven't done before, and please comment about it. Post in the comments anything that you might have done that this video or any of the other videos might have inspired you to do. And until then, have fun. I almost forgot. If you would like the files for this, they are on my Mini Factory. I'll put a link in the show notes. You'll find all of my designs on there. You can also find me on Twitter at ClockSpring3D. Okay, back to the music.